does
That's my guess.
say down here. So the group leader submits the group meeting link, which I'm assuming is the video that we've recorded. And then everyone um, just submits the first and last name of who attended and specify who's submitting the link. And that's all that it says about that. Then there is this. So one person posts the names, the problems you worked on, the answers you came up with. Um, and then I guess we comment on at least one other group, probably individually.
I think that's probably a separate assignment because this is compare answers with other groups. So probably this is
Uh,
probably
It's
after we do
linked.
this.
That assignment is linked right here, though.
yeah,
Yeah,
it's
but we'll
linked
do
to this
that
one.
after we do the first stuff.
Yeah, so that's just where we'll submit our answers. And then later, when other people have submitted theirs, that's when we will look at theirs and compare.
Yes.
Right.
But right now, all we need to do is up through part two. We can stop at part three for now and do that on our own later.
Okay. So I
Yeah, but
guess
I think that we should actually do part of part three,
Yeah, submit it,
like
but we don't need to
yeah, just
follow up
submit the
yet.
answers. And
Yeah.
then we can do the rest later.
Yep.
Yeah. All right.
Should we get started
Cool.
then?
Well, we're on the same page. Also, apologies that I don't have my camera on. I am not looking my best today, and I don't know. I can turn it on anyway if you really want me to, but
I
I don't
don't
want
have
you
a
to.
problem.
I don't want to see you.
okay.
Just kidding. I
All
don't really
right.
care. I'm not looking at you. So
Ezekiel, do you think it would be easier for you to do we want to do the screen sharing right here? Does this make it easier?
yeah, I
Or,
do have the assignment pulled up, but screen sharing is fine
and
too.
then I was gonna ask also if, since you're the one that's recording, do you want to do the screen sharing? Do you think that would make a difference at all? Or,
No, it doesn't matter.
okay,
It's just
then I
recording.
guess we'll just continue from here.
Okay.
So for limit laws, how's our confidence on that? I'm probably at a 7. It's
What are limit laws again?
I think so. The limit laws is, I'm not going to explain this very well, but just
It's okay. I just need a refresher.
probably just like rules of when something, just like how a limit is not actually the value, like right here. Actually, I'm going to use this point at x equals 2, right? The value at x equals 2 is 3, but that's not necessarily the limit. The limit is what it approaches as it gets to that x value.
Okay.
Um,
I would think that's more of the definition of limit. The limit laws are kind of there was one specific homework assignment last week that went over limit laws, and it was kind of stuff like if the limit equals this minus this, then that equals the limit of this minus the limit of that, that kind of thing.
Okay, and the
So,
multiplying of limits, you can either
yeah,
multiply the functions or do the limit of each function and then multiply them after.
yeah, kind of like that. Yeah.
Okay. Well, I'm also a 7 on that too.
Yeah, I would say 8 or 9.
All right.
Okay. So one-sided limits.
I would be at a 10 on this one.
If I'm looking at a graph like this one, then yes. If it's something that I have to solve a little more, without looking at a graph of it, it's a little more difficult depending on the situation, of course, but I think I'm still pretty decent.
Yeah,
Probably
it's
a
always
6 or a
harder when it's
7.
just an equation. have to do like problem solving versus just looking.
Right.
Now, these next ones, I guess that's the interesting thing about doing these meetings on Monday because these next two ones are stuff that we're covering this week.
Hmm.
So we haven't really done a whole lot of that yet, I would assume.
Right. But we
I
have
haven't
done,
started on the homework for continuity, so I kind of understand that.
and the continuity examples would just be like these ones, right? Where there's an open spot with a, an X value or a Y value that isn't along that line because it's
Yeah.
not
So
continuous.
yeah,
Would something like this one here also be? I mean, it's not a continuous line, so I would assume that this is also a continuity problem if you were focusing on this section.
yeah. So have either of you started with the continuity homework yet?
For this week, no.
Yeah. Okay. So let me basically explain the rules for whether a point is continuous. So a point is continuous if the y value for that x value is defined. So, like for example, uh, let's take x equals -1. The y value there is defined, and x equals -3. It's defined there too. And that's the first requirement. The second requirement is that the limit exists. So we can see that for -3, the the limit as you're approaching it from the left and the limit approaching it from the right is different. So that limit does not exist. So that point is not continuous.
Gotcha.
But let's say x equals 4, the limit of that, so the y value for that is 1, but the limit is 2, as you can see. So that does satisfy the first two requirements, but the third requirement is that the output of the function equals the limit of that value. So we have
Okay.
a defined output, a defined limit, and they equal each other. For x equals 4, that is not the case. So that point is not continuous. And a line is continuous if all the points on that line, or line segment at least, uh, let's say line, um, if all of the points on that line are continuous. So yeah, um, I hope I explained that well.
Yeah, I think that was explained pretty well. Well enough
Okay.
for me to know what it is, and I guess since I haven't done a whole lot of it yet, um,
I haven't gone over limits involving infinity yet, though. So
so
I don't know. It
limits
sounds to me like
involving,
a limit involving infinity would be non-existent, don't you think?
well,
I
the
Must be
limit
mean,
could
more
still
on there
be
because
there
it's
like
must be more than
unlimited.
that since we have an entire homework thing about that.
if we're looking right here, we've got as we're approaching from the positive side, it's going straight up. Approaching from the negative side, it's going straight up. So I think this limit here at an x value of 0 is infinity,
Yeah,
while there isn't a specific, you can't solve for x because it's,
yeah, it's infinite. Oh,
what's
and
this
let's look at x
called?
equals 2 as well. The specifically approaching from the left, it looks
Right.
like that limit is negative infinity.
Yeah. So from
So
here, this limit would
yeah,
be
there's
negative
that too.
infinity. And then from here, it's 3. So these ones are a little easier because usually you can look at the equation and if it's, um, if you just have, I'm trying to think of an example, I'm probably not going to be able to come up with anything, but like looking at a function where you can tell that as x goes higher and higher and higher, like if you just look at x squared, As x goes higher and higher and higher, so does the y value. And you'll get times where you can look at it, whether there's like a fraction or a square root symbol or something. You can see that it's just going to keep going up and up and up, and it'll never actually stop increasing. Um, and so
I think
some of them
x
are
squared
really
would
easy
probably be
to
a different.
identify.
I think x squared would probably be a special case though, because you can plug in any y value for that, right?
Right. I know that's not a very good example. I couldn't think of one that was like this x equals 0 value on the graph here. But, like you could just look at x squared and know that it's just going to keep going up. So some of them are fairly easy to identify. Some of them, like this,
Do we
at
look at horizontal stuff too? Like, for example, on the bottom left of the graph, there's that black point going all the way to the left that's probably going to never reach -1.
yes. So, yeah, the x would go to negative infinity, but the y value would just stay or would get ever closer to -1. So,
So now for part A, where it says x arrow 2 plus, where's that referring to?
this is saying, so find the limit as x approaches 2 from the positive side. So you're going to find 2 on the graph,
Right.
and you're going to start to the right of that and approach from the positive side or from basically the side greater than 2,
So
getting
that value
closer
is going to be 3.
to 2.
Yeah.
So yeah,
You just write down 3.
this would be 3 here. I guess I could do that with my annotation tool here. It's going to be really bad, so don't make fun of me.
So the answer is
Or
just 3.
yes, I can do that. That's not what I wanted to do.
As a Maybe you should make the text box smaller. Yeah,
I can't make it any shorter, so
or fine. Okay.
sorry about that. Okay, so as x approaches -3, now this is the overall limit. When you look here, coming from the left side, limit's -2, coming from the right side, the limit's -3, so this limit wouldn't exist. There is no limit there. So I'm gonna put does not exist. What the heck?
Why doesn't that one exist?
Because
Because it's continuous on the.
it's not continuous. So there's
Or
this
like because
gap
there's no
here.
technical break in the y values. Is that why?
So there is a break, right? I'm looking at the one, yeah, -3. So there is a break here. You're gonna read you're increasing an x value and you're getting close and close to -2. And at an x value of -3, your y value is -2. Apologies for my son. He likes to babble a lot. So,
At least you have a son.
and then if we look, so if we go at -2, right? Sorry, at -3, the y value is -2. If
Yeah,
we increase that x value by 0.00001 or any amount, suddenly
yeah,
we've jumped up to right here.
yeah.
And because if you're on this line segment approaching -3 from the positive direction, your limit is going to look like, well, your limit is going to be 0, and it's going to look like the y value also equals 0, when in reality, this is your true y value at x equals -3.
Right. But
Did I explain that okay?
yeah. So, why is the answer does not exist?
Because the if the limits on each of the one-sided are different, then that means the regular limit should be, equal to both of them. But if they're both different, then the regular limit does not exist. See,
So
because you
just
can't
because they're
define.
at different values, we write
Yep.
does
Yeah,
not exist.
So we
yeah.
could let's look at number
So
four
on the
here.
previous one with the line that goes all the way down and then the dot that's at 2 comma 3,
Right
why is
here.
that one 3? Is it
We are
because they do not technically, is it because
That's
there's
because
no second y value?
that's specifically a one-sided limit. It's approaching from the positive. We're not taking the stuff on the left into account
How come we are on the second one or the one below it or the one that we wrote
because
does not exist?
it doesn't specify that it's a one-sided. It's just a regular limit.
Is it
You
what
can
is
tell
that
if
what the
it's
plus means?
yeah,
Oh,
Yep.
okay.
yeah,
So this little it's not a subscript. What's that called?
superscript.
Superscript, thank you. This little
Mhm.
superscript of a plus or a minus tells you which direction you are approaching the limit from. If
Okay.
there isn't a superscript, it's the true limit, the limit from both sides, basically. So you can look at this one here. This is telling us as you're approaching -3 from the negative side or from the left. And then this one is 2 from the positive side or from the right.
Okay, that makes sense. That was what I was missing.
And I guess I didn't notice that it goes, uh, this one's actually the second one.
It's all the same.
So this one, the limit as x approaches -3 from the negative side. Did you find a book to read? So we look at -3, but from the left, meaning this line here. So this is our limit for that segment, which would be a -2. We already did that one. So then this one does not have a superscript. So it's just the limit at as x approaches 4. And
So
I'm
do
gonna
we write
try,
that
I have
one
a,
as does not exist since it's below the where the lines are?
so this limit does exist. Because what the limit is finding is what basically the limit is what the line looks like it's going to reach, not what the actual value is. So it looks like as you approach from either direction that this limit or this value is going to be 2. So that's your limit because it's approaching 2. The
Even
true
though it's
value
one.
at x equals 4 is this random dot because for some reason it doesn't actually equal 2, it equals 1.
But because they look like they're going to meet, that's what we say it's
That's what your limit
Yes,
is.
okay.
So this one is 2. And
yes.
I
It's
have a little
the
stylus and stuff I'm going to grab real quick. It'll make writing on this a lot nicer.
Yeah. Just remember that it's the limit and not the actual output. So it's just what that value is approaching.
Gotcha.
All right, let's see if I can remember how to use this thing. Okay, much better. Except for it unplugged itself. Sorry, it's having a hard time. Yeah. All right. Oh, I can't scroll when I have the annotation thing open. I
That's
also
okay. You
can't.
need to scroll, yeah, it's fine. All right, true. What's it called again? True limit at 0.
Yep, so as x approaches 0, which is going to be up here, So that limit is going to be infinity because both of these just keep going up.
Right.
What's this called? Is this an asymptote? Asymptote, right?
Yeah.
When they
Yes.
are when there's a
Yes, that's
line
right.
that they never equal. Okay,
Yep.
that was the word I was trying to find earlier.
Yeah, so that yeah.
The limit as x approaches 2 from the left,
That's also going to be
which
infinity,
is
right?
going right
Or
here.
negative infinity.
Yeah, that's going to be negative infinity.
The limit as x approaches positive infinity looks like it's going to be 4,
Hmm. And the next one's negative one.
and negative infinity, -1.
Yeah. All right, so there we go. That's the first part of this question. Now we need to find the what intervals the function's continuous.
Okay, I'm going to have to erase all of the annotations because evidently they are fixed to the screen and not to the
Yeah.
page.
Here, we might want to put screenshot them just so that we can write down the answer.
Okay,
So
All right, screenshot it. Let's go.
okay, cool. I'm going to clear that.
and now the second part.
I know the keyboard short
So
for screenshotting, so.
I always forget it. Doesn't matter how many times I look it up.
now over what intervals is this function continuous?
Do you have a
Um,
Mac?
So the limit as x approaches -3. Oh, wait, sorry. This is a different problem. I didn't notice
yeah,
that.
yeah, we need to do that part. So
So I'm gonna go right
Over what
here.
intervals is the
Looks
function?
like Brady's here.
So I'm guessing until the axis and or until the y-axis and beyond. There's the two separate. It's continuous all throughout the rest, right?
not
So
exactly. Remember, continuous means that um, the output and the limit exist and they equal each other. So there are a few points where they don't equal each other, like x equals -3. The
Okay, so
output is
basically just where
defined,
it
but
looks like it's continuous, it is continuous.
essentially, yeah.
Okay.
Except when
so
we're writing the intervals, it looks like we're going to need to use parentheses and not any brackets. So keep that in mind.
yeah, that's
No
what I was looking at
brackets?
too. So
Yeah,
like
no brackets.
for this section here, we know that this keeps going to x equals negative infinity.
Uh-huh.
So we
So we
would
were
put
right.
negative
Negative
infinity,
infinity,
and then
comma.
that interval goes to -3, but it's
Yeah.
not continuous at an x value of -3.
Yes, that's right.
So
Because
we
the
would just
limit
do a
there
parentheses.
is not defined.
Right.
And then our next interval is going to start at that -3. And of course, we know that it's not going to include that point. A bracket, if I
Hmm.
put a bracket like that, it means it includes -3, but this doesn't.
Right.
And then that goes until
Zero.
0.
The parenthesis.
Yeah.
Then
Another
we've got
parenthesis at 0.
0 again to 2, and starting
And
at
then
2 going until
would it be 2 and beyond?
No,
4.
because it's not continuous at 4. The
Well,
limit and output do exist there, but they're not equal to each other. So,
so even though we decided that the point at 4 was that the limit existed.
yes, but it's not continuous because the limit does not equal the output.
Okay. So if the dot happened to be at 4, then it would be, but it's
Yes,
not.
that's right.
Yeah. So if that wasn't there and this was just solid, then it would go
Okay.
from 2 to infinity.
Okay.
Yeah. and 4 to infinity. That's a lot of intervals.
It is. That's quite a few.
All right.
So yeah, I'm gonna screenshot
I already
this one
screenshotted
too.
it again.
Yeah,
He's too fast.
Deal with it.
okay. It looks like we have just under 5 minutes left, so there's a chance we might need to start a new meeting.
Yep. I guess I could
That's
probably
fine.
leave it right there and give us just enough space to see. So now we need to find the limit at -3. Oh, these are not based on the graph, so I can't
Yeah,
use
those
that.
are different functions.
Goodness, it's a Monday. It's very much a Monday for me. So all
And
we
now,
need to
now
do,
the easy ones, right?
well, mostly easy, because we can look at this and go, oh, if we're putting -3 in right at the bottom, we're going to have x plus 2 or -3 plus 2 over -3 plus 3, which is 0 at the bottom.
Yeah,
So it's
that's
kind of mean.
So that would be a asymptote, right?
not well,
Or no, what's it called? Undefined.
It,
well,
But
well,
if it's
the answer
undefined,
isn't.
does it mean that there's no point at that value?
There is going to be a limit because if you notice, there's a superscript right there, meaning that we are only approaching it from the uh, right side.
yeah, so we just need to figure out what it would be when we're approaching from the right side. So we can take a look at x equals -2, I guess.
Well, I
So
see, and this is where I know that there's something that we can do to this equation. We need to find,
yeah,
we need to make a denominator that can have a value at -3. But my thing that I struggle with is figuring out what that first step is. And I might be able to figure it out if I look through all my homework, because I spent a long time doing this on Saturday.
I actually don't quite know what we're supposed to do here. But it does say that we do only need to, like, let me double check. Yeah, it says we do only need to choose two of these problems to do. And I actually looked at number three and I figured out how to solve that one pretty easily. So we
Okay.
could focus on that instead, at least for now.
I'm pretty sure the answer, I think just plugging it in, I think the answer would just be negative infinity. Because I think for the denominator, because it's a plus, I think for the denominator, the answer obviously would be 0 at the bottom, which is undefined, and you normally you're supposed to find another way to do it. But like, I think when it approaches from the positive side, the answer would be negative infinity. I'm pretty sure.
Maybe.
Maybe, because
But
What
I
I'm
think
wondering,
I
since
think
it's
in
going to
order
be
to know for sure,
an
we'd have to do
asymptote
the
on the
homework
graph,
for infinite limits.
what if fraction graphs look like again? I can never remember. Like, how are they just generally shaped?
I think it just depends where the x is.
Like a 1 over x graph, is that what you're saying?
Well, in this case, it's a x over x graph, but I don't.
Yeah, it's a linear divided by a linear.
Well, a 1 over x, just to start off with something,
Yeah, probably
looks
all we
like
need.
that.
Okay, so then yeah, I probably would be. So we just need to decide if in what quadrant it's in, right? And then or like which direction it's facing.
So this one will
I actually
probably
I actually
be,
gotta go. So
Oh yeah, I
I think this is
guess
good enough
maybe
now.
the
But so just when you end the meeting, it'll save on my computer, so it'll be fine.
okay, sounds good.
I guess maybe the -3 then in that case would be an asymptote, and then we'd have to figure out whether it's pointing to negative infinity or positive infinity
Yeah, I think
Well,
that's
you
what
can
I'm
look
thinking.
at,
when
we
we're
can
approaching from
try
the
it
right
be,
specifically.
Or sorry, did we switch to number three